Let me log in. Who are you? All right, so let's get started right off the bat here. So with you guys have the preparation thing open?
Yes. Almost. Okay. You guys ready?
Yeah.
I am ready. So, did you guys do the thing where you cut out the papers?
I'm sorry.
I'm sorry?
Did you guys cut out the papers, or you got the mean of you guys know what I'm talking about?
You're talking about the homework number 7.
Yeah, number 7.
I figured we can well, I mean, I did that already up to B, but I can figure out C and D what they're kind of talking about. So, but I also figured we can just start over again so we're on the same page,
So,
collecting numbers, or new numbers.
sounds good. So,
So we have all the same data.
well, actually, we need different data. Because on 7D, you'll see why when we come to 7D. So,
Well,
so for 7A, I got for mine 46,980 for my mean. And you guys probably got different numbers, right?
I got 46,800 for my mean.
Mhm. So, Veronica, do you know what we're talking about?
No.
So on the
Number 7 on the homework.
on the third page of the individual preparation, there's like these squares.
Oh. Yeah.
Did you like
Oh,
cut
yeah, I
them
didn't
out,
have
or did you get 5? Sorry, did you get 5 numbers?
Yeah, the only thing is that that's the only part of the homework I didn't get to do.
Oh, okay, no worries. So, you have those. So, just yeah. So, do you have those numbers cut out somehow, or do you have a place where you could
Take them out?
select 5 randomly and then just add them up and then do the mean?
Yeah, I'll do that right now.
Okay, cool. Yeah, then we just need the mean. You just need to get the mean and then mark it on that graph.
Let me just do it really quick. Sorry.
No worries. Yeah.
Okay, I got 42,640.
Very good. So, let me see. Okay, so now let's go. So on B, it says this graph illustrates the sampling distribution of the sample mean. There are 142,506 possible combinations of the 30 salaries, drawn 5 at a time. This graph represents the distribution of all possible samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A. Everyone good with that?
Yeah.
Okay, sweet.
So, I mean, I figured out which point. I don't know if we can actually put it in the graph.
Yeah, I just mark it on there. No worries. So, does your sample mean appear to be unusual? Explain why you think it is or is not unusual. For me, my ended up like right in the middle. Like it was 46,000 something. So it was pretty much right in the middle. So I felt like mine was no, it's not unusual. But
Mine's about the same because mine was 46,800,
mm,
so just a
yours-
little bit more to the right than yours.
yeah, yours is really.
Of course, I don't know what makes it unusual. I
Probably
guess if it.
some edges like Veronica, you said yours was 42,000.
Yeah, I think mine's unusual.
Yeah. Yeah, I think so. I think I'm guessing that's the only thing that makes a difference. You know, if it's in the middle, it's probably normal. But if it's on the
Well, I
sides,
think it described what makes it unusual that much in the lesson.
yeah, I didn't really focus on that.
Yeah.
So compare your mean from question 7a to the means obtained by at least three other individuals. What do you notice? Practice, you only get to see the means from samples you draw. You do not get to observe any other mean that could have occurred. So, like, yeah, we pretty much compared them already because me and Clayton got really similar ones, but you got a different one, Veronica. So I just goes to show, you know, it can be really different sometimes. But it's only three, you know. It's
Yeah.
probably really, you know, you could see a ton of possibilities happening if we had like an infinite number of people doing this. So, what about number 8? The Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration (MBA) programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample, or n equals 10 students taking the GMAT. What is the shape of the distribution of the sample means for all such samples? What is the shape of the distribution of the sample? Let's see. Well, what the, did I invite a different Praying Banks?
Oh,
Oh,
gross.
Okay, so the call ended. Was that because of my computer?
I think so because I didn't experience anything.
Well,
Yeah,
I
you're
mean,
double on here.
your face froze up and it sounded like a robot. And it was just extreme slow motion. Uh, I could hear your voice in slow motion. That's pretty much it.
You're on the screen twice too, bro. So it's kind of weird looking, but we'll go with it. So what do you guys think? What's the shape of the distribution of the sample means for all such samples?
Where do you go? I mean, where are you guys?
Oh, we're on 8A. Did you?
Okay, so I'm still on D.
Oh,
It,
we didn't
it,
have to answer anything for D. Or did we?
I mean, you were discussing D. You were reading out the question, and then that's when you were talking in super slow mo.
That's funny. So I don't think we have to fill anything out for D. I think we just have to discuss like what we noticed. Basically, what we noticed is without like a huge number of samples, we can't really see the distribution. can't really see how much it would be distributed, but we did see a little bit that Veronica's was on the low side, so it can be a little different, but it's just kind of random. But once it gets to a bigger sample size, then it gets to be, if it was up in the hundreds or the thousands, it would be pretty high and pretty noticeable what kind of distribution shape it was. So basically, the number 8 says the Graduate Management Association admission test, is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample or sample size equals 10 students taking a GMAT. What is the shape of the distribution of the sample means for all such samples? What do you think, Veronica? Do you have an idea?
Well, I'm trying to figure. I had a little hard time with this one because of the whole applet thing that he had us looking at.
Yeah.
How are we really supposed to know? Like, because I don't know. I think I just didn't understand it. So I was reading what it is, but it's just saying it depends on the sampling distribution.
Well, I mean, earlier I tried inputting this, trying to figure out using the applet. I could not make that much sense from the applet. I mean, when I was doing the lesson, I did all the steps and all that. I only noticed a few changes, not that much when it came to the different distributions. I don't even know how you calculate that, but I think it mentions something in the lesson about if the population mean is normal, then what is it? Then the sample means is normal. I don't really know.
Well, okay, so this is what I understood. If there's two, so if the parent population, if it's a normal distribution, then the sample means are going to be normal distributed no matter what the size of the population. But if it's skewed, if the parent population is skewed, you're going to have a large sample size for it to be normally distributed. So like on the applet, you could, when you did skewed, I would always just push like plus 100,000, and that would show automatically like, oh, if you have like 100,000 samples, then it's normal. It's going to be right in the middle of the data, and it's going to be like a pyramid, and it's going to be normal. But if you do it like one at a time and have a low sample number, it's going to be all over the place.
Mm-hmm. Well,
that's why I mostly got out of the lesson. Like, the larger your sample size, the more normal.
Oh, okay, that makes a little more sense.
That's one of the rules from what I remember, and I noticed that too. The more samples you have, the more normal shaped, I guess, it is.
Yeah. Wheat.
But there's not really any.
So the answer is I'm trying to think if it's a 10. Is that a big enough sample size?
I thought it wasn't. I thought it'd have to be bigger sample size for it to be normal.
Oh, I totally just got the answer by reading it again. So the scores on the GMAT are normally distributed with a mean of blah, blah, blah. That means that the shape of the distribution of the sample means of such samples, the letter A, it's got to be normal, because that was one of the rules that if the parent population is normal, if it's normally distributed, then your sample mean is going to be distributed as well. It's normally distributed, not skewed, not the other one. Any thoughts on that?
Well, you're cutting in and out, so. But I pretty much kind of got what you were saying because that's kind of what I was saying a little bit earlier. Something about, the parent population being the same as the sample. But it looked like most of the rules indicated a lot of normal distributions or something like that.
Yeah. The only case it's not going to be normal is if it's, if the parent population is not a normal distribution and you have a small sample size, that's not going to be normal. It's going to be all over the place. If you go to the applet and do a skewed and then just do one at a time, you're not going to get not until you get up in the hundreds. Like in the hundreds or the thousands or so, you're going to get some good, normally distributed data.
Yeah, you're cutting in and out again. Let's go ahead and move on.
Basically, I was saying if the population is normal, the mean sample is going to be normal. Large. The mean sample is large.
Sorry, guys.
No worries.
Sorry, my sister had to run out, so I have her kid. Okay. I kind of got some of that. I think I kind of get it, but...
All right, I'll go through it one more time. So, think of the applet, and if the parent population is normal, then the mean sample, no matter what you do, is going to be normal, no matter what size it is.
Oh, okay.
But if it's a skewed, it's only going to be normal if the sample size is large. Once it's smaller, like on the applet, if you add a sample one at a time, it's going to start out all over the place. But once you get a large one up in the thousands, the 100,000s, it's going to be normal. It's going to stay normal.
Oh, okay. Okay.
That make sense?
Yeah. That makes more sense.
I think that time I was cutting out.
I think you get it though, Clayton?
Well, I mean, if you're referring to the parent population being normal, meaning that like if the parent population is normal, that the sample sample mean is normal, then yeah.
Yes.
But what makes this parent population normal? Just that it's using.
Oh, you mean for the question?
Which question are we on?
We're on number 8.
Well, we are. Yeah, I know we're on 8, but which A, B?
A.
I mean, because A. I mean, I guess B would pretty much be what we said about, what you said about the parent population.
Yeah.
Yeah,
exactly. Yeah.
But
so
what? Oh, sorry.
Yeah, I was just saying. A. All you have to write is normal.
Yeah.
B is just like kind of what I was explaining, and I think a short way to write it would be because of the it's the large number theory. Is that what it's called?
I don't think that's it.
Called.
There is the law of large numbers.
Yeah.
The law of large numbers.
But yeah, what I was asking is what makes number 8 like a normal, like the parent distribution normal. I mean, I get what makes the sample means normal.
Good question. That's what I found. If you read over the description for 8 again, so before we get to 8A, it says on the third line down that So starting at the second line, it says the scores on the GMAT are normally distributed.
I skipped over that.
No
Okay.
worries.
So I guess we can go ahead and move on to C.
So actually, hey, just quick thought about B. Sorry, but I think it's because of the central limit theorem. Actually, I was reading the description of that. So yeah, I'm pretty sure it's the central limit theorem. Read that in the text, and I think it'll match up to what I was saying earlier, more than the law of large numbers will. Does that make sense?
Well, the sample size in this is only 10 students.
Yeah,
So-
exactly. So the central limit theorem is going to match up better with that because it says the distribution of sample means is normal when x bar is normally distributed, or when, yeah, thanks to the central limit theorem, your sample size is large. Or you know what? For B, you can just put because the parent function or the parent graph
population
is normally distributed. I think that's the best answer.
because, basically for A, the sample means is normally distributed, and we were already talking about the parent population being normally distributed, so
Yep.
I thought we already answered that.
All right, cool. I feel better about that. Alrighty, so C, what is the mean of the sampling distribution of sample means according sample mean scores for all such samples? Sample distribution of sample mean scores. Isn't it?
Isn't it the 529?
I think so.
Yep.
So you use the same mean for all the samples, wouldn't you?
Yep. I read about that in the text. I think the mean's the same no matter what.
Yeah.
So, but this next one is interesting. What is the standard deviation of the sampling distribution of the sample mean scores for all such samples? And this one, you take the you take the standard deviation, which is 113, right?
Yeah. And then you divide it, right?
Yep.
You do that equation that divided by the square root of the sample.
Yeah. So run that through the calculator.
Divided by the square root.
Okay, so I have it, and you guys are ready.
Yeah.
You guys have 35.7.
Yep.
Yeah.
7 3s, 3 7, whatever.
Yeah.
Just 30. Yeah. So there you go. Sweet. I think we are ready for the quiz.
Give me 1 second. Okay, sorry about that. All right, let's get started.
No worries.
Okay.
Okay.
Just a sec.
Answer the first two, and then
Okay, so I'm ready when you guys are for number 3.
alrighty. When taking samples of n when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
Yeah.
Oh, I bet you we could just... You guys have the applet open?
Yeah.
Yeah.
I bet you could use that.
I mean, I think I got normal, but it's just to the left.
I don't.
Kinda.
It's skewed to the right, isn't it?
Yeah, so you have to do a custom one.
Well, if you put skewed, then it's already going to the right. Or it's skewed to the right.
Oh, is it? Or is it...
Or is it
Well,
to
yeah,
the
just
right?
click on skewed, check for yourself.
Are we're supposed to click on skewed, right?
Well, I mean, we can do custom. Like, if they were asking for a left, we'd probably have to do a custom.
Isn't... I don't know what it looks like on yours, but it looks like it's on the left to mine. To me.
Is the tail on the right side?
Yeah, the tail's on the right side. Is that...
And
Yeah.
that's right.
Oh, it's skewed right?
From what I remember from the previous lesson, I believe that is right skewed.
Okay.
So it's opposite when you're saying it?
I didn't think so, but I thought the bulge... Oh, wait.
Okay, so I kinda... Okay, now looking at it, making sure that n is 5, I did notice that it is kinda... I mean, it looks normal, but then if you look at both sides, it's kinda skewed right a bit.
Oh, dang. Oh, wait. I don't know. I'm confused by this. All right. Huh. Well, I'm all confused now. I don't know what... I don't know which one's right. But,
I don't know either.
huh.
Oh, this is
Nice if it was like...
Let me see.
If this said skewed right or skewed left.
So are you guys still on 3?
Yours?
Sorry?
Yeah. Well, yeah. Yeah. What was it? N. Well, because I'm trying to figure out if this is the right skewed. I always thought that it was that the bulge was on the right side, but I guess I could be wrong. Because I googled skewed right grafts, and it had both. It showed both. I might just try here. I might try just doing that again and see if there's
Distribution historical rates. When taking samples, what is distribution? Wait, pay attention to what it's asking. Hold on. Okay, let's do that.
All right, cool. Let's just. All right, I think I looked up on a website, and I'm convinced now that it's. You're right.
4-3.
Right, right. Speaking. So let's just say. Yeah, n equals 5.
I think it's not normal.
Well, once you get up into higher numbers, it'll be normal, but it's not necessarily saying that.
Well, yeah, for N5, I think that it has just a tiny bit of a tail. For the most part, it's normal, but it does have a tail skewing to the right, so I think it's right skewed.
I would say right skewed as well.
You don't, or you do?
I would say that, yes.
Okay. And then I went ahead and looked at 4, and the highest we could put is N25 from what mine says. And I think that it's normal because it's close together.
Normal.
But it's asking you what happens to the parent population when it's right skewed.
Oh.
So number 4 is actually the same as number 3, but N is 100. So the highest we could do is 25. So we just input 25 and then just click on 100,000 a few times just to be sure. And I use both graphs. So the N5, that's where we got the right skewed, almost normal. And then the other graph I put N25, and that one looks more normal.
I would agree. Since the sample size is so large, I think we're safe to put normal on that one. What do you think, Veronica? What are you thinking right now?
I agree with for the number 4. I'm not understanding number 3.
So I'm not quite understanding either, so let's look at it together. So when taking samples of n, when n equals 5, what was the shape of the distribution of means histogram?
I think the best way to describe it is to go ahead and, how there's 4 graphs. I would use both the third graph and the fourth graph. And one of them both of them make sure they're on mean, but one of them put n equals 5 and the other one equals n25, and then hit the 100,000 a few times, and you'll see the difference.
Do you keep it at normal or do you keep it at skewed? You skew it, right?
Yeah, skewed.
If we're doing 3 or discussing it, then yeah, the parent population is right or skewed.
Yeah, you can see it even better when you add 5 at a time a couple times. So do what Clayton was saying, like put the bottom graph at a mean of 25 and the second to bottom graph at 5. And then on the sample data buttons, control panel, whatever, click 5 a couple times and you'll be able to see that the third one down is somewhat right skewed and the fourth one down is normal.
So if I'm looking at it and it looks like it's leaning to the left, that one, it means it's right skewed?
Yeah, when the bulge is on the left, I just looked it up, and if the bulge is on the left, it's right skewed.
Oh, okay. Okay. That's
So
what
it's
it was
confusing because
confusing
I
me.
thought the other way
Tail.
too.
Well, like if the smaller end, the tail is pointing to the right, then it's right skewed, and the opposite for left.
Exactly.
Okay.
I'm
So
gonna
it's
look.
opposite of what you would think it is.
Yes.
Got it.
So
I'm gonna look at the website real quick about that actually, just in case. I'm not really sure. But we can move on to the next question. So number 5, when taking samples of N100, what was the shape of the distribution of means? Okay, it's normal again, right?
So we just do the same thing on the 100, right?
Yes, it would be the same.
Wouldn't it be the same? Because I know it doesn't go on the applet, but wouldn't it be the same? Wouldn't it be normal?
Yeah, it would be normal
Higher,
because
the more normal it gets, right?
it's in the parent. You could even say the parent function, parent population is normal anyways, so that makes.
Yeah.
So, does that make sense, everyone? So number 6, what?
So I think I just blanked out on that. So what did you guys find out for 5?
That it's normal.
That's what I thought. Yeah, let's go ahead and go to skip.
When would the distribution of means be normally distributed? Choose all the correct responses. Okay, this is easy. Okay, so the first one. Data are drawn from a population that is normally distributed and the sample size is small. Check. Right? Because the parent population is normally distributed.
Wait. Sorry, I think we're wrong on the other one.
Which one?
On number 5. Because it's saying what is the normal distributed, and the other one is what is the right skewed.
Yeah.
So it isn't. I don't think it's normal.
Oh, it's annoying. Sorry, there's a fly in my kitchen. I'm all messed up here. Clayton, there? You can't. I'm having a hard time seeing. Oh wait.
There I am. For some reason, it crossed out the video and the microphone, and it logged me off.
All right, cool.
So what were you guys saying with 5?
So with 5, I think it is still normally distributed. The question is different, but it's still normal because the parent population is normal. So,
Yeah. And I thought that too, and I also looked at the whole histogram thing, and both of them look really normal.
I think it's normal still. Does that make sense, Veronica?
No.
No,
Because
okay.
don't you have to change it?
Did you make sure that you changed the skew to normal again?
Yeah, I did that, and then when I animated it, it didn't. It
Oh,
looked.
that's why you click animated, and that only does one sample. Try clicking on 100,000.
Oh. Okay, got it.
There you go.
Yeah, because like the samples weren't large enough. Or,
Oh, I see. Oh, okay. Okay. Yeah, I got it. Sorry.
No worries, no worries. We're doing this for understanding, so no worries. So, number 6, when would the distribution of means be normally distributed? So checking all that apply here. So data are drawn from a population that is normally distributed and the sample size is small. I believe that's a check.
yeah.
Yeah.
And the second one, I believe that's a check as well because the population is still normally distributed.
Yeah.
Number 3.
I think it's. Isn't it all but the third one?
Yes, I believe it is.
Because if you for the right speed, if you have the large, it's normal, right?
Yeah, if you have the large, it's still normal, but if you have the small, it's going to be messed up
Okay.
somehow. Okay, which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean x bar will follow a normal distribution. Okay, let's keep going. For bell-shaped data, approximately 68% of the... Okay, that's not it. I'm not even going to read that one. That's definitely not it. If the sample size is large, the sample mean x will be close to the population mean.
I think it's that one.
Sample size is large.
Because I know it's isn't the theory like as the mean gets large, I mean, as the size gets larger, the mean gets closer?
I think that's the law of large numbers.
Oh.
Clayton's right.
I think it's the fourth one. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal.
Oh, yeah, sorry.
No worries, no worries. So do you think it's the last one? Is that what you're saying?
Yeah.
Distribution of sample mean is normal and x is normal distribution. I think that is correct as well. Okay. Yes.
Yeah.
Sounds good. It's tough actually because I don't know. What do you think about the first option? What do you think the first option could be it too?
Yeah, it does kind of look like it.
Normally the sample mean x. Actually, distribution of sample means is normal when x is distributed or when things. Let me look up a different part of the central limit theorem.
I think it might be the first one.
I think I'm leaning actually towards the first one as well. You have
Because
these simulations that oh. Okay, let me think. Okay, that's that definition. Actually, I'm leaning towards the last one now because there's a different definition in the textbook towards the top in chapter 2. It makes it more clear. Or not chapter 2, in section 2, where it says the central limit theorem. You guys have that open?
Mm-hmm. I'm looking at the very bottom.
The bottom is not as clear, but look up towards the top where it's section 2, and then the second paragraph. It says,
Well, at the bottom, if you look at the first part and then the second part,
yeah,
basically talking about the sample means being normal and is normally distributed when our sample size n is large. And number 7, if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. So it's just saying it in the opposite way.
Yeah.
So yeah. I think it's the 7 is the last one.
I think it is the last one, yeah.
Yeah. Okay.
Okay, let x be a random variable with the population mean something 10 and the population standard deviation of something 6. You suppose a sample size n equals 36 is drawn from this population. What is the mean of the distribution of sample means? Right?
Mm-hmm.
Wait, what now? What's right?
10, I believe. Because it was saying in the reading how for the distribution of all sample means, the mean is still the
The
same.
mean never changes, remember?
Oh.
So, what is the standard deviation of the distribution of sample means?
Oh,
What?
so what was 8? Just to make sure, because you're blanking in and out. So is it 10?
Yes, 10.
Yes. Sorry.
Yeah, I'm only catching bits of what you're saying, so that's why.
See what I just put in the group?
So say what now?
I put something in the group chat,
Yeah, that's
and I can use the group chat if you'd like, and that might help it. So just in case you miss anything.
yeah, okay.
So I'll put that in there when you need me to repeat something or something.
All right.
So what is the standard deviation of the distribution of sample means?
So is that where you do the
Yeah, you do the equation.
yeah? So I have 1.
I think it'll be 1. Yeah, I haven't finished it yet, but I'm pretty sure it'll be 1 because
Let me input it just again, just in case.
36 is 6 over 6, which is 1. So I believe it's 1.
Yeah.
Yeah, and even when I look it up in my head, that's what it looks like.
Regardless of the distribution of the population, if the sample size is large, over 30, what would be the shape distribution of the sample mean?
I think I remember that. I think it's normal.
I believe it's normal as well.
Yeah.
What theorem? Sorry, I'm getting tired, so I'm doing weird accents. Okay, so what theorem would justify your response to question 10?
Wouldn't it be the law of large numbers?
I think it's central limit.
think. Let's see. Let's look at the definition of both of them again, because I am not 100% sure. Because it could be both.
Oh, hold up. Regardless.
So the law of large numbers.
Might be the law of large numbers. Actually.
It says here the law of large numbers states that as the sample size n gets larger, the sample mean, x bar, will get closer to the population mean.
Yeah.
Let's look at our question again. Regardless of the distribution of the population, the sample size is small. I'm thinking.
I think she was right the first time because I looked at the definitions real quick, and I think it's law of large numbers as well. Because basically, the larger the number for the law of large numbers, the closer the mean is to the popular mean, or something like that. And then central limit is basically the larger the number, the more normal it is, or something like that.
I hate to say this, but I'm actually thinking it's the central limits theorem because the central limits theorem has to do with. So, let's think. The law of large numbers has to do with the mean, excuse me, and the central limit theorem definition makes me think it's more about the shape of the
Wait, hold up. Now reading it again. Shape. Oh, okay, yeah. So actually, just as they said, when I was talking about the two different terms, it 10 is actually asking for the shape. I mean, like I think you were about to say, and I think that's yeah.
So that's actually really good learning because I just learned that for myself. I didn't realize that. That's the difference between those two. That the central limit theorem I think deals with the shape of the graph, and the law of large numbers deals with
How
Wait,
close
you said that
the
both times.
deviation is, or uh, means is what it says. Yeah, so they both have to do with the shape of the graph, but basically central theorem has to do with the larger the number, the more normal it is, and then larger law of large numbers, the larger the number, the closer the means are.
so. Mensch. Ah, man, that's a tough one. They're very, very similar. Can't figure it out. It's a toss-up. But I'm leaning towards the central limit theorem.
Yeah, I think it's the central limit theorem because basically for 10 we put normal, and for question 10 it was asking what would be the shape of the distribution of the sample means, and it's asking like normal, skewed, bimodal, while like if it was asking about like law of large numbers or something, it would probably be asking uh, are the means closer or wider?
All right, let's go with that. I like that.
Okay.
So do we feel good? Let's go through the. Let's just run through the answers again real quick. I just want to
Well,
make
I
sure.
already clicked, so we got 100.
Oh, we did. Good. I'm glad you took one for the team.
So
Well,
it's central limit
pretty
theorem?
much thought we were good.
Yeah. So the answer is central limit theorem.
Yes, and I apologize to the teacher for helping you guys cheat, in a sense. Not really.
Well, we worked it out,
Yeah, we did.
and we were confident. Cool. So, any conflicts on Thursday? Do we need to do this later again, or?
I mean, I think every Thursday is when I have to meet with my secretary meeting thing. But I'm also trying to discuss between two different. I have like two projects each with where it's like a group project. I think this Wednesday, or sorry, tomorrow, I have to meet with them. Or I don't think we discussed the time or what the heck we're doing, but I mean, and then the other one is like Saturday, so that's not a conflict. And that'll be easier because all I have to do is take videos and junk like that. Be doing crazy, stupid stuff. But I guess for the most part, for my secretary meeting, my calling, it's